All right, progressing with the setup to hot melt extrude. The original Orifice, I believe this one, and again trying to follow the patent, just had a straight drilling in a standard pipe plug. So you can just get these at the Napa store. We've got a counter bore, and it's just a plug. So made out of brass, I thought that would be good. So the first one, I drilled out a counter bore in the back, and then drilled through reasonable wall with a drill that would shape the extruded material to the right diameter. Well, that didn't really like the way it squirted out, so again, trying to interpret the patent a little better, I made a second one, and it's basically got a step where there's a small orifice that provides the back pressure, and then a larger part of the drilling to hopefully kind of shape and that. And that seemed to be a slight improvement. And then to take it one step further, I decided to add a piece of brass tubing to kind of shape it and keep it coming out straight during the hot melt extrude process. And it turned out that the drill bit, 3/32, formed a hole that was bigger than the 3/32 tubing. So it kind of wobbled around, and I thought, well, maybe I'll just put a little Loctite on it. And then when the Loctite set, I could see that it had actually gotten into the hole a little bit, and it was a little bit crooked. And then I got to thinking, you know, this is going to be heated probably to enough of a temperature that the Loctite will soften. So I'm going to try and reproduce this one out of my last blank, and just try a smaller drilling and then force the tube into the smaller hole. Another thing I'm doing on this third or the second attempt at my third orifice is I'm boring it out so the plunger can actually go all the way to the bottom, and that last little bit, which is actually quite a lot of volume, that will actually mean that I get a larger output, or a larger net quantity of the extrusion. So the way it was before, the plunger came down and would hit the plug, but it would just leave a solid mass of melted HPC, and then I'd have to clean that out, or just it would come out the next batch. So here's a little close-up of the barrel and plunger. Again, this is out of a fuel pump. This is a ceramic plunger, which works very well for not welding itself to the other part under high heat and pressure. And what I have to do is basically push it all the way through with the orifice removed, and then put the orifice back in, fill it with powder, put the plunger back in, and I can do a one shot. So this setup is really just a one shot. But just for Teresa's use, that's not too bad. One shot easily lasts a month. And as I'm making changes, it's more of a proof of concept to try and home in on it. Anyway, here's kind of a drawing of the third. I'm also going with a smaller drilling, because we found that we really couldn't back up the pressure and get all of the gases to escape, and we were left with some bubbles in the extrusion. It wasn't a nice clear. So hopefully through these drain holes on the side, the gases or the air would escape, and then we'd have more of a solid to get pressed through.